in terms of getting library or anything else?
No, there is no challenge in running.
Okay, perfect.
The
Now,
only thing is not able to practice sufficiently.
I would say one thing, that how the ideal learning is. Do not make it. Do not pressurize yourself that you are going to mug up, or you are going to put everything on top of the mind. Okay, what happened that when we learn more and more, this application of ggplot is going to happen almost in each and every technique. So things will fall automatically. My suggestion is that we should ensure that what all code we are learning, are we understanding the logic? If you are understanding the logic, what is happening, then that is fine.
Sir, there is a suggestion. If you can give us a couple of questions also, as you have given in last assignment,
Okay.
that helps in understanding, because you start applying your brain, in terms of why this is happening. Otherwise, it gets skipped off from your mind very quick.
Well. So in every exercise, in every technique, we have some questions which we'll certainly share. So I will share some questions and expecting you all to write the code and come up with your solution. Yes, it is there.
Right.
So in previous code, let me clean my environment. First, I'm going to read my data. And data reading happens. Then I run this code, and we know the reason that why this code was run. This one, the last code of the previous class, wherein I suggest the geometry and I pass some coordinates that where this graph is going to plot, and this is what we got. Fine. Vishal, you need to mute your mic. You're getting some disturbance. Yeah, now it's fine. Now, it is this is what we run in the previous class. Now, what I'm going to do, I'm going to add. If you want to add some labels here, the coordinate we added, something additional you can do, like you can add some labels, and you are saying that in terms of labels, I'm saying labs, and in labels you are saying that your title. Adjust my laptop. Yeah, title, you are saying that your title is going to be write anything like area versus population. These are all aesthetic. Aesthetic is the thing that we are going to add it. Now, then you are going to add something called subtitle. Subtitle, you can add the subtitle. And the subtitle you are writing like using Midwest data. This is your subtitle. Okay. Title happens, subtitle happen. Then you want to say something for y-axis. So after this one, put comma and say that, let me put here only because it will all visible together. And here I'm saying y is going to be like you're writing population, that is done. Then you are saying that your x is going to be like area, and if you want to give some caption, so you can give some caption like caption caption. You can give some caption like you can say Midwest demography. Fine, you just added it. Okay. I hope everything is fine. So let me run. So I wrote everything correctly from my standpoint. I just need to run it. Yes. So look here what happened. Recently I added these labels. I'm saying title, area versus population. So are you getting here on the top, area versus population is coming? Then saying subtitle, using Midwest data. So look here, subtitle is coming downside. Then you are saying that your y is going to be population, so something like population is written here, and x is saying area, so at the x-axis area is written, and caption you are saying that Midwest demography. So look here at the bottom, Midwest demography is written. So usually in the caption, people like source. Like you can, if you want to write this one, you can say source. Normally the way people declare. So let me give a better better meaning that why technically we use the caption. So in caption, if you want, you can write the source. That what usually in the published paper we find it. Yes. So now let me run it. That will look better. So in the caption, if you're writing the source, it looks good. Look here. Now this is how people published the report. Are you getting it? Is looking it is ready for publishing. Getting it?
So can we use the same code on other chart as well?
No, it is only part of the ggplot. So in ggplot,
Okay.
be careful. You need to understand one thing, that how ggplot is working. You must have seen there are many plus. Look here. This is one part of the code. This is doing something. After putting plus, I'm putting this part. This is doing something. Then again I'm putting plus, and then saying that this is doing something. Then again I'm putting plus. So be careful. These are the plus is saying that additionally we are going to add many things. So that you can do in ggplot only, not at the other place. Is that clear? Now I'm going to ping this data. In case you want to run, you can run it. I pinged it. I hope it is running. Is it running for you?
Yes, Chinmay.
Yes. Now, so this is how. So understand, ggplot is something which is like. Yeah, tell me.
It's showing me the error, that error in Google ggplot. Couldn't find function ggplot.
So you need to run library. So you need to first run library, then run ggplot.
Okay, let me do.
Hello, Chinmay.
Yeah, tell me.
Yeah, sorry to interrupt you. Actually, due to some personal emergency, I have to drop this call. I have to drop this class only. Um, so I'll see the recording and then I'll get back to you by tomorrow. Is it fine?
In weekdays, it is. You can mail me. Again, depending on
You
my
can mail me.
slots and all, I will reply you. But in weekdays, I have different obligations. So you mail me. We'll see that how what best can be done.
Chinmay,
Okay.
it's showing me the error
Okay, yeah.
again.
Okay,
That
thank you.
it's showing me the error again, that there is no package called ggplot, and I've tried to install the package. Then also it's showing me the error in installing the ggplot. Object ggplot not found.
So can you see in your library ggplot is visible? If you go to the library, go to package. Sorry, here package. In package, can you see ggplot?
Let me see. Let me see. ggplot2 is here.
Right. So if ggplot2 is visible, like in my case, uh, in my case also, are you getting ggplot2 is visible here?
Sorry?
Now you need to run. If that is the case, that means library installation happened. You need to write library and then write ggplot. Can you try with calling library ggplot? Because oh wait, let me write ggplot2. Yeah, this. So you need to write library ggplot2. This code you need to execute.
ggplot2.
Right.
Let me see it. Yes, it's running then. And after that,
After that, run the code.
run the code in ggplot only.
The code which I pinged.
Yes, that you pinged. Let
Yeah.
me check. No, again it's showing me the error.
What error? What message is coming?
It's like error in ggplot df underscore midwest comma AES and df midwest not found.
Wait. I'm going to ping you the complete code. You run that. What I'm presuming that the one which I explained in the previous class, you people are on the track. So do one thing. Now run this code which I'm pinging now.
Yeah, please.
I pinged it. Run it.
And
Hello.
For that area which is population title, can we also use main?
Your voice is not properly audible.
For that area which is population title, can we also use main?
You can write
The
anything.
keyword title.
See, wherever you are writing something in the quotation mark, you are free to.
No, I mean for the code, you've written title, right? So can
Okay.
we use main there?
You're talking about there?
No, not there.
Huh.
Where you've written title. Instead of that, can we use main?
No, it is only coming with title.
HN is done now.
So title, understand, there are two things. That's what I wanted to sensitize, that
Okay.
this is title, subtitle, X, Y, caption. These are predefined keywords. Getting it?
Okay.
You
Okay.
cannot alter it. Okay?
Okay.
Now, inside the quotation mark, what I'm writing, you have only provision to change it.
Okay.
Got it?
Because earlier when we were using title on the top, we used to use the code main.
So there we used to write main, yes. So main comes when you talk about your normal. So in the labels, it is the title.
Okay. Okay, guys.
Got it? Now,
Thank you.
I hope this is working for everyone. Anish, it's working. Ashish, it's working.
It's working now.
Perfect. Because that data was not there in your place. Okay. Now.
Yes, it's working.
I'm not getting the captions and other details.
Not getting the. So are you running my code?
Yes, sir.
Not getting the caption.
The other details, axes and other things are there, but not the captions you have mentioned. Graph is there.
So can you zoom up the graph? Sometimes it so happen that
I have tried to did that plot zoom. On the left side, there's a POP total. At the bottom, it is area, but nothing in terms of legends and captions.
Captions are not coming.
Because it is also showing errors in some line. Okay.
And you are running my code only.
Yes, sir. Yours only. Probably there is some mistake, probably data and specifications.
Recently, I again pinged the code with data and library ggplot. Can you try once again?
I will try it.
Recently one, wherein it is I read the data from the URL and then we are running this query.
Chinmay,
Yeah.
I'm not able to see the title on the plot.
So for you,
It's
title,
only showing using data.
for you, title is not coming.
No.
So for some people, caption is not coming. For some, title is not coming. These are. I do not have any specific answer that why it is happening.
Like the subtitle is appearing, but the title is not showing.
We need to find out why it is happening. It should not happen in that way. But currently, I do not have answer that why it is happening.
Okay.
And you are running the
Hi,
exactly my
Chinmay.
code.
I am able to get the.
Yeah.
You are running my code only. Still, you are
Yeah.
getting.
Yeah.
Uh,
Mhm.
is there anyone who is getting the same issue with title? Title is not coming.
Yes, sir. As I have told you, the next, even though I have tried the
No, for in
second
your
one
case,
also,
caption is not coming or title is not coming.
both, neither captions. I mean, the entire text which we have added is not coming.
That
Probably, I think there will be some kind of an interference with the new one, because I'm using the same sheet. Probably that could be the reason for this. I will do it on another file, new file. Probably I will get it there.
My part is fully coming, no issues.
Title is not coming, source is available.
no title. Is there anyone else who is not getting the title or this label part is not coming? I added something here. I'm just checking that is there someone else also who is facing the same issue?
Yes. Sleep Pratik.
Pratik,
No.
now you tell me that those who are facing the issue, are you using Windows 10?
Yes.
Okay, because I'm trying to understand why it is happening. This is Windows 10. Okay. Papri, in your case also you are using Windows 10?
Chinmay, I'm using Windows 10, but I'm getting all the titles and subtitles and captions, everything.
Yeah, same here, Chinmay. I use Windows 10 and getting everything.
I am also using Windows 10 and getting all.
I'm also Windows 10 user.
And things are coming.
Yes, sir.
So do you know these are kind of bugs. So if you ask me that why it is happening,
I have tried to restart the R Studio, so now it's coming fine.
so these are
But
bugs in your system. These are bugs. So if you ask me, I do not have any question, any answer that why it is happening. Either system show you some error or it is not going to happen for anyone. But if it is happening for someone, not happening for someone else, so there is some bug.
But, yeah.
Now I think that is done. I will showcase one another way to just for illustration purpose that how can we store this ggplot object. So the same code which I wrote, I am writing here. I just copied it. What all was written on the top, I copied here. And once I copied, I want to store that by name of something called, let's say, G. So I'm saying G is equal to something. Okay. And then I'm going to run it. You need to listen it very carefully. Reason being it is a good concept. So currently in my environment, we have only data frame. And the moment we are running this one, I do not want anything to be printed. Let me first clean my printing area. I cleaned it. Then moment I am going to run it, it is going to store my process in an object called G. So look here, there is something called G is stored. Fine. Now, it's your call. If you simply call G and then run it, it will print you the entire graph. So what are you doing? You are storing this graph as an object. And if in case that is required, you are hitting it and you are getting the output. That means what all process in the graph is happening that can be stored in an object, like an object. Now there is additional advantage of this. I'm going to add. So again, I'm going to clean it. I cleaned it. My G is already created. Now, then I'm going to add something here. I'm saying G plus and saying like scale underscore x underscore continuous. That is perfect. And then I am saying breaks is equal to it is going to be sequence, and I want to start from 0 to like 0.1, and I want a sequence of 0.01. This is one thing I did. Okay, and similarly I'm going to do for y, and then I am saying g plus, give me some space for better visibility, scale underscore y underscore continuous, and then I am saying the same one, breaks is equal to sequence 0 to, let's say, 1 2 1 2 3 4 5 zeros, and then we are going to have uh, 540. You can have the number. So I added something to define my x and y. If you remember, in the earlier case, without running the code, I'm just going to run the g here, the g which I stored. Wait, your x and y is coming like this way. It is automatically taking some sequence like 0 to 0.25, 0.50, 0.75. Now I'm saying that is not going to work. You are making some process like 0 to 0.1. That's how it is going to be. So we are adding something. Similarly, for the y-axis, also we are doing the same one. Now, then I'm going to run it. So let me clean it, and I'm running it. Now you can see that how your graph is coming. Are you getting your x and y is now proper visible? In previous case, your population was coming differently. Are you getting population was coming in scientific number here?
Yes.
Now the moment you did it, it is, wait, just a moment. Let me clean everything, and then I'm running it. Yes. Now your graph is coming wherein you had, like the way you make the breaks, you are making breaks in your own way. Even on the y-axis, you are defining certain way that look how your y-axis is going to look like. So technically, you are adding some information for x and y-axis. So, and this is useful on top of the graph. So you have your graph. Now you are going to add something in the graph with the plus sign. You can add in the original as well with the plus scale something, but it is suggested that whenever you want to do something with a coordinate, first you store your original graph, and on top of that you do this scaling. Clear? So this method is known as wherein we are storing the graph as an object, and on top of that we are performing some task. So I'm going to ping it. You need to try. Let's see if it is working. Can you try this code?
Yeah, this is working.
Is working?
Chinmay?
Yes. Okay.
Chinmay?
Yeah.
Prasad here. I have a query. You added before 50,000 was in sequence. What is it? 1 lakh some? 10 lakh.
Okay. So if you remember, I explained a process called SEQ, sequence, and I'm saying 1 to 10. Let's say 1 to 10 with 2. What does it mean? It is going to print number like 13579. Getting it? That's what I'm saying. That I'm saying print from 0 to this one, taking a width of this much.
Okay.
The width of 50,000. Yeah.
Okay, it's a range.
It's a range, correct.
Yeah. Okay, understood.
That is fine. I hope it is working for everyone. Okay.
Yes, sir.
Now, I am going to do slide change. Someone saying something?
Sir, one query here. So just like in the plot area versus population is coming there. So this is predefined or we can change it?
You can change it again. If you go through the entire code which I wrote, I said that what is going to look in my X and what is going to look in my Y. Getting it? So according to depending on your data understanding, you can change it.
Okay.
Got it?
Okay.
I'm going to do another level of tweaking in the same data. So we are going to generate or we are going to develop different understanding. So be careful here. In the geometry point, I said shape is equal to 16. Now I am going to change here something. Okay. Now I'm saying that geometry point is going to be, now we are saying aesthetic, and in the aesthetic I am saying that color is going to be the state. So there are different states that is given in my data. That is one thing. And second, size is going to be, let's say 2, and I will plot it, the same graph. Okay. So let me clean it. I did some changes because that will reflect or showcase that what is happening. I think remaining all stuff are the same. Mathematically, color is equal to, let me do one small change, or method is equal to geometry smooth, method is equal to linear, color is equal to, okay, I did not dashed here, so let me remove it. Line dashed is not required. I'm saying color is equal to black. You can change any color. You're saying color is equal to black. So geometry smooth, method is equal to linear. Perfect. Method smooth, method is equal to linear. And let's let me try it. Method is equal to linear, color is equal to black. Done. Let me run it. I hope it should not throw any error. Yes, that's what I wanted to plot. Okay. So look here in this graph, first understand that what is happening. In the different states, if you want to plot those dots, because each and every dot in your plot is indicator of one record. Getting it? So by looking at the color, you can understand that how the behavior of different states is in terms of area and population. Getting it? So I added that color is equal to state because I wanted to fill those dots with the state color. And size, like if you change the size, as I explained, size 2, 3, 4, that give you the different types of the shape. And the color black I did because I wanted this line to be black, not the dotted. That's the reason that I removed dashed. I was not looking for dashed. I wanted a non-dashed line. So are you getting the difference? What happened the moment I did change? Technically, I did change here on this part. That's the only change. There is no other change which I did. Method linear was already there. Earlier I added like dashed. Now I remove the dashed. If you want to keep dashed, you can do it. Did you see the change? How it is happening? And I hope you understood the meaning as well. Is it clear?
Hi Chinmay, could you please once again try explain? I got to know, but I have a little bit. Could you please repeat it another time,
Certainly.
please?
Okay, I will do it.
And
So
also about that size, Chinmay.
also
Equal to 2.
okay. So I deleted the entire what I wrote. I'm going to perform the redo of the entire task. Okay. So the previous code, I just copied the previous code and I pasted here. Okay. Now you remember here in the geometry point, I said that shape is equal to 16 and color is equal to dark gray. Okay. Now, and the moment I'm running that one, let me clean it. If I, that previous graph, if I run it, you are getting how these colors are coming. So you say that you want shape at the point, the geometry at the point, shape as 16. So that how shape of 16 is coming. And you say that the color is going to be dark gray. So your all dots are coming in a dark gray. I think that you understood that what happened here.
Yeah, that part I've understood. Yeah.
Okay. Now, then I'm saying that I do not want, be careful, each and every dot in your graph is one row. Getting it? That is indication that, like, if I open the data and if you go to a column called state, here it's coming. So just a moment. State. Okay. Are you getting that IL is one state? Again, IL is coming. Again, IL is coming. That means each and every record is having a state identity. Got it? That means IL is coming many times. Now, considering that, I wanted to, here looking at the graph, I can't figure out that which all dots are coming for IL, which dots are coming for JP. So that I could not understand. That is the reason that I wanted to add some color schema, that this dot should look like a different color. And considering that, I deleted these all. I deleted. Now I know that my geometry is going to be point. Okay. Now then comes the in point. How are we going to do it? Let me again clean it and run it. Just a moment. Did you see what happened here? When I didn't say anything in the geometry inside, I said geometry point. So everything is coming as point. By default, it is taking the black color, size, whatever it is doing. Is that clear?
Yeah, that part is clear.
Okay. Now then what I'm going to do inside, I want to change the look and feel of these dots. So in that case, for look and feel, there is a function called aesthetic. So now I'm going to change the aesthetic. And in aesthetic, first is color. I'm saying how my color is going to look like. So I'm saying that color on the basis of the state. So state is one variable. So I'm saying that for different state, you use different colors. That is fine.
Yeah, that is fine.
Okay, now let me run it. So if I run it here, wait, I'm getting some warning message, but that will come. It takes some time, but that will come. It is all talking about the memories. Yeah, it has come. So now did you see what happened here? Earlier your all dot was coming in black, now it is coming in different color. Is that clear?
Yes, Chinmay. It is taking the colors of the state. It's referring to the states.
Correct. That's what I did. Then coming to size. So if you add here something called size, if you say that size is equal to 3, let's say you are saying size is equal to 3. So that size decides about that how big this circle is going to look like. Again, though I need to close my R and R Studio because it is showing some memory issues, but still I'm going to run it and see what is happening.
Under product.
Wait, it will come.
So, Chinmay, previously you had used shape and now you're using size. The shape between 16 to 18.
Yeah. So in previous case, you're talking about which one? This one. Size.
Yes.
So
Now
shape.
you use size.
Yeah. Shape is indicator like circular, triangle. That's what the shape is. Size is indicator like font size, bigger, smaller.
Okay, the font.
Got it? I'm just waiting for this graph to come. After that, I will clean my some cache memory. So let it come. And these are the challenges in R or Python. We do not go for complex graphic. It does not support that level of graphics. Wait. Let it come. Meanwhile, I'm going to just clean my temporary memory. I hope now it should work properly. Let me rerun it. It's all about the size. So if you add some size,
Hello, Chinmay. While it's loading, can I ask another question?
Yeah.
Yeah. In this code where you've the scale of x is continuous and the sequence is between 0 to 0.1 with an interval 0.01. The interval on the graph isn't 0.01 when it shows on the x-axis.
Right.
It's like 0.25. Is it calibrated accordingly to the data?
It is calibrated according to the data, but the way you made the provision, it is doing provisioning in that way. Though it is displaying like 0, 0.25, 0.5, etc. But it is.
Exactly.
But if you look at the lines, I think.
Because in the y scale, it is calibrated fine.
Right.
You set the interval.
In X also it is doing the same one. It is not displaying the value. Now look here. Did you see the moment I see size equal to 3, this circles are bigger?
Yes.
Yes.
Yeah.
And now you can see that everything in area, things are coming. So it comes properly. There is no that issue.
So, but on the y now it's scientific.
Again, it is. I would say it is more about the system issue, but it calibrates.
Okay.
It calibrates.
Okay.
Got it? Now with that, it should not be that problematic. Just a moment. Let me close my R Studio. Then again, I'm going to open it because what I realized that it is becoming slower and slower. That should not be the case. This was what I was running. Yes. And this is the 2 data points I run. Perfect. Let me just give one more attempt to get it, if things work properly. Some other task is happening, so that is occupying some of the memory, that conversion. So no worry, just wait. I'm just waiting for this graph to come up.
Chinmay, I will read out a message.
Mm-hmm.
Warning message. Can you please explain this? Error G plus scale underscore X underscore continuous within bracket breaks is equal to sequence 0.1.01 non-numeric argument to binary operators. In addition, incompatible method operations dot of frame within inverted commas GG. It's saying that there is some error in this whole operation.
It is, I would say, it is more like incompatibility issues. Okay, just do one thing. You mail me that message. That what message is coming. Okay. I will, because I also need to. Just a moment, guys. I think it is. I need to start. I think it seems that that notebook is that workbook is heavily loaded. So let me start at the other place. Let me create one new project, and then I think that may be easy. I hope now it will be faster. Yes. So now I understood the reason that why that was happening. So it so happened that in your one project, things are heavily loaded. It looks like that way. And now coming to the question of the x-axis. So if you look at the way it is doing, getting at the grids and all, it is considering, it is not displaying the way we pass your x label, but it is internally it is managing that. That's what is apparent here. On the y-axis it is apparent, it is visible in the graph, but in x-axis that is managing. So that is one of the command, but it is not visible here due to the data length or due to the data width, the way your x-axis is coming. But that is the correct syntax. If I increase this like from to 1, it is essentially going to 1, and then if I change it, this is correct. I think there is nothing wrong. This is correct. It is taking care. In y-axis is visible, but in x-axis it's not visible, but it is arranging or organizing your data properly. And the message I heard someone is getting, you are getting on the scale x continuous. On top of that, this is what message is coming. Is that? I just listened. Someone was saying something. Oh, this is error. Continuous break sequence. This one non-numeric argument to binary operator. In addition, warning message. So this is coming as warning. It's coming as error. Okay.
Yes, sir.
So yeah, here it is saying that non-numeric argument to binary operator. Non-numeric arguments. Your x-axis is numeric. Let me check it. X-axis is area, and area is numeric. Wait, let me find the class of this Midwest.
Also, I'm not getting all the variables on population side, x-axis.
Wait, it is numeric. So I like the way message is coming, which is saying that non-numeric, but like the message, your message is there. It is saying that non-numeric argument to binary operator. In addition, so it is numeric. It's not so it's not non-numeric. Getting it?
The rest of the things are fine, yeah. But on these axis population, I'm not getting all the numbers. I'm getting only 4 numbers. That too, it is not showing the full length of it.
I will check it. And that in case of technically in the x-axis it should display like 0 to 0.0, like 0.01, 0.02, 0.03. Technically it should do. Yes. But I think some changes.
And y-axis.
Yeah. Y-axis is coming.
Y-axis, it is only showing 4 this thing, and that too also 6e plus 0.5 and 4e plus 0.5, not all entire numbers.
So your y-axis is not coming like this?
No.
Let me do one thing. Let me delete this.
Can you ping us the code?
Wait, I will ping it. So let me do one thing. It's a one shortcut. I just wanted to see that is it following the same manner on the same process. When I deleted that X scale, I wanted to see is it following the default 0.0 scenario. I ping the code. So I would say that for X and Y scale, I will figure out that why it is happening. Technically, it should not happen. For some people, it is coming properly. For some people, it's not coming properly. So I will check. I think remaining other than this X continuous, Y continuous, I hope the previous codes were running fine.
Yes. Yes.
So for this scale, I will figure out why it is happening. Now, with
Chinmay?
Yeah, tell me.
Can we customize our colors for the states in the previous chart?
You can customize.
Is it possible or not?
It is possible. Yeah. You can, the way you are passing here, you are saying that your color is going to be state. So for different, like you can say that the color is like for different state you can pass, but those colors you need to write like an object and then say that if state is LL, then color is going to be this. If state is something LT, then color is going to be like this. So that is an additional argument that you need to write.
But just wanted to check the compatibility there.
That is, you can do it. You must have seen that without passing a lot of arguments, that's what the system is doing. So do not go for very complex graphics in R or Python. Your system won't support after a certain interval.
Okay.
I got it. With this a new code, I'm able to get the entire thing.
Right. So the X is creating, for in your case, X is creating that is issue.
No, now it is perfectly fine. Both x-axis and y-axis. Got it.
Oh.
Probably I think I have must have missed some kind of while copying the code.
Maybe. So now that is your X and Y both is coming fine?
Perfectly fine, yes. It is from 15,000 to 6 lakhs for y-axis and 0 to 1.1 for x-axis.
Okay. Fine. Is there any further question?
Chinmay, could you please ping first 2 lines also?
First 2 lines?
Yes.
These 2 lines?
Yes.
I pinged it. Now, with that, we did the scatter plot. So we saw a lot of things on the scatter plot. Now, I'm moving on something called histogram, and I will showcase some additional behavior. Histogram. Okay. In the histogram, I'm going to take that diamonds data. So I'm saying diamonds is equal to diamonds. I'm going to work on that diamonds data. Oh, I'm getting a lot of in structure X class. Let me clean everything. I think this conversion previous class conversion is going on. This is occupying a lot of memory. I think that is the reason that it is throwing me that message simultaneously. Okay. Now this diamond is my data, previous class data that we discussed. Yeah, this is the diamonds data. On this diamonds data, I'm going to perform some task. So first, I'm going to say ggplot, and it is going to be as I did previously. I'm saying df underscore diamds diamonds is equal to diamonds. I'm just storing one set of the data just for the safety purpose, nothing else. So I'm saying df underscore diamond. I'm referring it, and then saying that aesthetic is going to be x is equal to price. Aesthetic is, so this equal to is not required, writing wrong. So ggplot df diamonds, aesthetic x is going to be price. Perfect. Then adding here, in adding I'm saying geometry geom underscore, and I'm looking for histogram. Okay, and then saying color is going to be, you can pass anything, like color is I'm saying red, and you want to fill those colors, so I'm saying that fill is equal to orange. Okay, let me run it. Color is equal to red, it's not taking. Okay, so let me,
R should be capital.
No, if even it is, the color is taken in the lowercase only. I think the other color, let me take it. I'm taking black. No worries. So I think red is, oh wait, geometry histogram, and geometry histogram, I put 2 bracket. That is one issue. Yes, it takes, right? That was the reason. Yeah, that was the reason. Okay.
Yeah, double bracket.
Double bracket was the reason. Okay. Now, did you see what happened here? I said that first I said histogram and I said that color of the histogram is red. So you can see that boundary is coming with red, and inside that I wanted to fill with orange. Clear? Now, so be careful what I am doing here. As I mentioned that my x is equal to price is variable. I am saying this one variable name on which I am going to run. So I am running on the price. Then this is geometry underscore histogram is the geometry. I'm saying that this is what the geometry I'm going to use. And after that, I'm passing this color, etc. If you do not say anything, like if you want to try it, simply say, let me see, because we never did like this, but you can try. Wait, if you do not say anything, simply say geometry histogram, it is going to create histogram. But those additional options wherein color is equal to black, fill is equal to orange, that is what we are customizing. Is that clear?
Chinmay, I'm getting an error over here, which is rlang colon last error bracket to see where the error occurred.
Wait, I'm going to ping my code. Can you run my code? Wait. Yeah, I pinged it. Could you run that code?
Yes, I'm going to check this. Yeah, it's working.
Working?
Not sure.
Now, then see what I'm going to do. I'm going to add one statistics on this graph, not on this black and white graph, but on the colored graph. Okay, you can add here also. There is no hard and fast rule. So I'm saying, in the previous case, what I did, what all I run here. This is what my graph is. Okay, and that is perfect. And I'm storing that as something called Q. So I'm saying Q is equal to this one. And if I run it, this object Q is created. So you can see in my this one in environment, this Q is there. Okay. Now, then what I'm going to do, I'm saying Q plus, I'm saying geometry underscore V line. I wanted some vertical line. I will tell you what is the meaning of vertical line. And saying that how the aesthetic is going to be. So in aesthetic, you are passing x, not coming, x, in aesthetic I'm saying x intercept. Oh, this option is not coming. V line, geometry, geom underscore V line, aesthetic, x intercept. This is code is correct. No worries, if not coming, we'll run the code and see if any error is coming. We'll validate. I'm saying mean of the price. I'm going to do perfect, and after that I'm putting comma and saying this color is going to be blue and line type is going to be cast, yes, and size is going to be 1. I want a thin line. Okay, so I just added here size is equal to 1. You see what is happening. Wait, did you see a vertical dotted line on your previous graph? Here vertical dotted line, the blue color line is there.
Yes. Yeah.
Now for that I wrote this code. I'm saying that geometry, I want a vertical line. That's what the geometry is, V line. Then saying the aesthetic, where it is going to look like. It is going to intercept on the x-axis. So saying x-intercept. Where it is going to x-intercept? So you're saying that it is calculating the mean of the price. So price, for the price, it is going to calculate average. So you are saying that this line is going to cut x-axis at the average price. Then saying color is equal to blue, line type is equal to dashed, and size is equal to 1. So if you increase from 1 to 2, 3, 4, this line will become thicker and thicker. Is that clear?
Yes, Chinmay, one thing over here, this is correct. I can see that you place the label as price even in the previous graph, but on the y-axis count has automatically come.
That comes by default. Because when you plot the histogram, your y-axis is frequency by default.
Yes, okay. Got it.
Now I'm going to ping this code, try to run it. Pinged it, try to run it. Is that running fine?
Yes. Can you explain like what is this? What we are saying is the mean of.
Yes, I will explain. So what I was saying that in the previous graph, if I reiterate, in the previous graph when I run this part only, we got this graph without this dotted blue line. That is clear?
Yeah.
Now let's say that you are presenting this graph to management, and the management is saying that, can you tell me where is the average price? Where is the average price falling? Getting it? So you wanted to add an indicator for the average price. It's a blue line. It's saying that, look here, like this is the blue line is the value which is the average. So let me run here. I'm just going to calculate mean. If I run mean and say that in diamonds, this is 3932. This is what the average is. Getting it? So
approximately 4,000.
Right. So you wanted to plot a line which is close to 4,000, so that anyone can understand that what is the average price and how the distribution is looking like. Got it?
Yes.
For that, this entire task is happening. I'm saying that geometry V line, I want vertical line. How is the aesthetic? You say vertical line, fine, but I'm saying that it is going to do the x-intercept. It is going to cut on the x-axis. Where it is going to cut? Mean of the price is going to calculate. Fine, on the mean value. Then we are saying the color, line type, size. That is fine?
Fine, perfectly fine.
Hi, Chinmay.
Yeah, tell me.
Just like when you created a new project, I had also created a new project. How do I like go back to the earlier one?
Earlier project?
Yeah.
Okay.
The ones that saved earlier.
Again, if you come here on the right, are you getting this R symbol here? There is drop down. In drop down, if that project is visible, you can go. If it's not visible, you can't go.
Oh, it's not visible.
So you have not saved it properly.
Okay.
Now, then you have to manually find. You have to manually find that where that project is. Okay, go to the folder, and then you need to double click on that code file, then only it will open. You cannot open from here.
I see a lot of folders calling 8-stack. I have to manually open all the folders.
So
R6.
you need to manually find, because from here you can't find it. Either you store that as a project. If you're not storing, then you need to manually find it.
Okay.
Now, when we come to the technique part like linear regression, logistic regression, that time I will explain how to create a different folders, because it may require that for your linear regression, data, code, everything you are going to store at one place. Now we are going to talk about box plot. So yesterday we had discussion about the box plot. I explained something, but again I'm going back to, let me find where is the PPT. '84. 83, that's what we did. We just run the same code and we got the output, similar output. Then this is how the output we had. Then we're going to talk about the box plot. Okay. So for that, your geometry is, in the geometry, if you hit the box plot, am I audible? Guys, am I audible now?
No.
Yeah, I think in between for a couple of seconds, it was showing that my audio was not proper. Now, we are going to talk about the box plot, and in that case, your geometry is going to be like geom is equal to box plot. Okay, that give you the box plot. You remember in previous class, I explained that technically box plot is plotted in horizontal in the learning context, but your statistical tool, these tools plot in the vertical, but in the academics, this is always presented in the horizontal way. Getting it? Now, these are what the whiskers are. Fine. These are the whiskers. These lines, the thin line, blue lines. As you remember that in the previous class, I explained that your this line is the minimum line. This line is your 25th percentile. The yellow line is your median. Then the next line here is your 75th percentile, that is known as Q3, and then this line where my currently cursor is, this is known as maximum. That is clear? Now, at the same time, I also explained that box plot is a process which it's a plotting which help us to know the outliers. Fine. Like, I hope I run in the long back. So if I say that C K is going to be C by 2, 4, 7, 9, and then 6, 8, 4, 5, 8, 6, 7, 5. I'm saying box plot, and in that I write the K. This is how your box plot is going to look like. Okay. So if you simply write the box plot, it looks like this. What I'm doing in this data, my data is like 2, 4, 7, things are very close to each other. I'm going to write a big number, let's say 30. Did you see what happened, how your box plot is looking? Your box plot is here, but there is one point also here at the top. Is that clear? This point is known as outlier. So box plot is capable enough to figure out that is there any outlier in your data. Is it clear?
Yes.
Now, it happens in both the contexts, both sides. It's not so that it's only going on the top. Like in my data, if I write,
Chinmay, just for a while, it can also indicate that there is an error in the data. See, so for example, there is one point which is going out of the way. Maybe there is a data which is different, but there is a possibility that there is an error in the data.
so again, error is subjective. So you once it identified that there is a point which is extremely or
Yes, you can.
different from others. So as a subject matter expert, we need to figure out that's an error or it's not an error.
Yes. Say for example, if you are taking in height, say for example, height as average of 5 to say 6.2, and suppose there is a figure which is giving a 10.2.
Right.
So there is a matter of genuine suspicion that this may be an incorrect data.
Right.
So you can go back and check.
Yes, that's what it is doing. So because see, whatever the intelligent system you develop, end of the day, it's only human who is taking the decision.
Yes.
The system will highlight that this point is like different in the mass, but you need to decide that it's outlier, it's error, or something.
Right.
Now, let's say that my data points are like 200. So here I'm writing 200, 400. So everything I'm making as 100. 900, 600, again 900, 400, 500. And finally, one point is only 5. Okay. If I plot it, oh, wait, this number is very small. 200 is there. Wait, it's again a distribution behavior, nothing else. So I wanted to showcase dot at the bottom. So sometimes it happens that you can see dots in the bottom as well. Wait. I think it is proper. Something wrong is going on. It is not giving the proper result. But you will be getting at the bottom also. It is considering starting from 0. That's how it is going on. But that won't be the case. You will be getting some dots at the bottom as well. Like here.
Yes. Now we got it.
Yeah. So it comes. So it is not so that the dots only come on the top. It also comes at the bottom. Getting dots at the bottom is slightly tough. Now, so if you see here that in your data, either your dots will be at the bottom or your dots will be at the top. Getting it?
Right.
These are the indicator of the outliers. It comes both the sides. Now, the question comes that how do system identify these outliers? So be careful. This is Q1 and this is Q3. Fine. This is Q1 and this is Q3. If we take the difference of Q3 minus Q1, this is known as IQR, that is interquartile range. Fine. So there is a term called IQR, that is interquartile range, that is technically the difference of Q3 minus Q1. I hope that is clear.
Yes.
Now, what your package software or the system does, it calculates one number like Q1, this Q1 value, minus 1.5 IQR. It's a number. If your number at the left side is less than this number, then it is known as outlier. So it performs mathematics, and that mathematics is Q1 minus 1.5 IQR. And we get a number. Getting it? If on the lower side, if a number is less than of this number, then that is considered as outlier. On the right side, on the positive side, if again Q3 plus 1.5 IQR, if a number is bigger than this one, then that is considered as outlier. Is that clear?
Hey, this is Q1 plus and Q3 minus.
Is that clear?
Yes, it is clear. Can we take a practical example by giving figures? Say for example, Q1 is 10, right? And IQR is say 55. So what we are saying is 10 minus 1.5 into 5, which is 7.5. That is 2.
Do one thing.
What is the inference in this?
Wait, if I run I hope this summary will not work. Yeah, I got this value. Okay. I got this summary. Q1 first quartile and Q3 third quartile.
Right.
Okay. Now then I'm going to calculate IQR. So IQR will be 750 minus 450.
Right.
Okay. So my IQR is going to be 300. Okay. Then question is saying that according to theory that Q1, that is 450. Let me go back here. It is saying that Q1, that means your 450 minus 1.5 into 300.
Right. Again 450.
Okay. If I run it, I am getting at 0. Okay. So it is saying that any number which is less than 0, okay, will be outlier. Now let's validate here. So here I am writing minus 2. Okay. And then plotting it. Are you getting? This is able to detect minus 2 as well?
Right.
You got it?
Yes.
Now, at the same time, let's find the at the
higher side one.
Upper side.
Yes.
So upper side is saying that again. So IQR we got, and here I'm naming it LB, that is lower bound, lower side. Okay. This is what my lower side is. Now I'm going to calculate UB, upper bound, UB. So upper bound will be calculated as 750 plus 1.5 300.
Yes.
Clear?
1200.
Yes. So and then see what the UB is coming. Your UB is coming as 1200. Got it?
1200. Yes. 1200 minus 900.
So this is what it's coming. So in your data, if you write something like 1200, but be careful, the moment you are putting 1200, your numbers are going to change. So I'm writing some bigger number like 1500. Okay. I will tell you the reason, and that's why I'm doing so. Are you getting here now? It is showing on there is a outline. Did you see that?
Yes. Yes.
So that is how the theory or how the fundamental is to know the IQR. Now I hope you people understand.
No, it is even this 1200 is more than the highest one, 900. So which it
See, why I wrote bigger number like 1500, I will tell you. Considering that number, if you run the summary, okay, are you getting the third quartile and the first quartile is changing? Getting it?
Yes. Okay.
So the way we are calculating, like Q1 minus 1.5 IQR, Q3 plus 1.5 IQR, we are calculating considering this outlier number, not excluding that outlier number. That was the reason that I wrote a bigger, even the far bigger number.
Okay.
Got it?
Got it.
Now, I hope this interpretation, this explanation is clear to everyone.
Yes, Chandra.
Okay.
Yes.
Now, then we are moving to the coding part. So I will do some coding because we did a very healthy discussion on the box plot. It was question in the previous class how to interpret. We come to know the interpretation. So again, I'm going to use diamond data. So I'm saying ggplot and df underscore diamonds. This is what my data is. Perfect. And saying that aesthetic is going to be in X is going to be clarity. X is going to be clarity, and your Y is going to be caret. That is perfect. Then aesthetic X is equal to perfect. It is done. Then I am passing third argument. It is saying color. Color is equal to going to be again. You can say clarity itself. So depending on the clarity you want to have this one. Depending on the clarity, I am slightly suspicious on this code. I will tell you why. Then saying geom, I'm trying geom underscore box plot, the way we just discussed, and I'm not doing anything. So I selected it and run it. I hope it should come. Wait. Yes, it has come. So now you are getting what is happening here. For different clarity, I am creating the box plot. And depending on our understanding, we can do the interpretation. This graph is clear?
Yes. Please ping the code.
I will ping it. Did it. Try it.
Yes, it's working.
Got it?
Yeah, working fine.
Okay. Now, then we are going to talk about line plot. Okay. That's how the line plot is done. I am just going to experiment. I will be taking the same data, but diamond data is this one. Aesthetic, my X is going to be, let me find some good quality variable. Otherwise, this will not come too good. So one is price I'm going to take, and other is carat. Fine. So my price and carat. Okay. So I am saying that price and carat. So aesthetic X is going to be price and Y is going to be carat. I need not this color because it's line 1, so no need. And geometry is going to be line. Both are numeric, price and carat. Perfect. Let me run it. I hope it should run. Today my system is a bit slow. So because your data is very huge, you can, I'm just going to zoom up. This is what it's a line plot. So for each and every price and the carat, it is plotting that look how your data is looking like. Your data is so huge, that's why it is coming like forest. It seems that the army is standing. Clear?
Right.
But this is how your line plot look like. So you will be getting technically, if your data is small, I will showcase how does it look like line plot. Your line plot look like this. Clear? On the less data points. I would say that it's your call. If you want to have line plot, do it. But if you do not want, again, if you the number of records are too huge, line plot is not going to make any sense.
But we can put a limit, as you explained yesterday.
You can put the
number of limit command.
You can put the limit, but be careful. We are talking in terms of the price and the carat. If you are going to put any limit, that means you are not going to get the proper output. So it's better that you think for some other type of charts.
Okay.
Getting it? But yes, you can put the limits and you can get it done. You can say that what the X limit is going to be, Y limit you can add on. Got it? Now, in the graph itself.
Just for a while. Because why I'm saying is that you need not touch both the variables. You just need to define price. The second variable will come by default.
No.
Say, for example, we are saying that price range is from say 40,000 per 10 grams to say 50,000. So carat will come automatically, or probably we can keep the carats constant, maybe 24 carats. Isn't it so?
So what will happen in that case? Though it will only display for those X, but it will take the complete space for the Y variable. If your Y values are, let's say, ranging from to 2U, so your Y bar, that Y axis will be longer. Getting it? But yes, you can try. You can try and see that how it is coming.
Right.
Now, then coming that, what if you want to have some different line type? Let me find in that, I think when that data I dropped. Okay, let me do one thing. I hope I will be able to do. I'm saying diamond 2 is equal to diamonds and I'm saying square bracket and I'm going to take records, let's say from 1 to 300, 1 to 200 and all the columns.
Spelling not correct. Spelling not correct.
Spelling? The spelling is not correct.
Not correct.
Yeah, DIAMONDS. Yeah. Now it is coming. Okay, now I have diamond 2. So at the place of diamond, if I say diamonds 2, I just subsetted the data to give you a good looking graph. Now you are getting that your line plot is coming?
Yes.
I just subset it. So you can do subsetting the way you want. It's your call. Okay. Now in this, if you want to add something more like your line type is going to be like dashed. So it will give you the dashed line. Getting it?
Right.
If you want to add something like color is equal to, let's say red, it is now in the red color. Remaining all options, X limit, Y limit, if you want to add some captions, you can add anything because this is all coming in the ggplot. You just keep adding plus and add those options like your limits and all. You can go on. Clear?
Yeah. Please ping the code.
I will do that. So now, then I'm saying that in case you want wider, what I say, line. So in that case, you can at the place of this line type is equal to dashed. Okay, let me add it. No worries. Line type is equal to dashed. I'm adding another that's called size. Size is equal to, let's say, 1.5 and putting comma. And then let me run it. Are you getting thick line is coming? So you can add it.
What is the default size, by the way?
Default size is 1. That's how, again, it depends that which updated package you are using, but default size is 1.
Okay, okay.
I ping the code, you can try it. Do one thing, I'm going to the above line which I didn't ping. So let me ping the complete code so that your graph is coming. So I did the subsetting of the data. So you can also do subsetting.
That's fine, Chinmay.
It's running fine.
Yes.
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 Now this was your last code of the ggplot. Okay. I will showcase some real example that what is happening, and that is too early for you. Most probably in the classification, like in the logistic regression, I will use those types of code. But I just wanted to showcase that there are certain questions that where do we use these all graphics? Okay, and for that, I am going to showcase one case study. Though it's too early for you, but you will be getting some sense. Okay. So now with that, I'm going to start with the data. I did some pre-processing, which I have not explained you as on date, but I will showcase how ggplot is useful. It is only for ggplot. Do not ask for any mathematical process which I am doing. Just look at how plot is informative in case we want to plot something or in case we want to do something. Okay. So I'm going to file, open file, part 1. Yes. So I have Titanic data. Okay. That is Titanic disaster. Okay. Wherein it's original data. If you know the name of that lady, the real lady who survived, okay, you can You can find her name as well here. This is the Titanic data, okay, Titanic disaster, and this is part of one of the case studies as well. So let me first showcase the data, then you will come to know. So your variables are like passenger ID, passenger survived or not survived. So like wherever 1 is given, that passenger survived. Wherever 0 is given, passenger didn't survive. Passenger class, in which class passenger was traveling, in first class, second class, third class. What was name of the passenger? So name is given. What was the gender of the passenger? Male, female. What was the age of the passenger? When people were traveling, how many siblings they had with them? How many parts they have? What was the ticket number? How much they paid the fare? If they got the cabin, what was the cabin number? And from which place they boarded on the ship, embarked. So there are 3 places from there where people embarked. So this is the data that is available on the Titanic data. I hope data understanding is clear.
Yes.
Now,
Yes.
What is parts?
Which one? Parts.
Parts.
It is here. Parts is saying number of parents or children aboard. So let's say that someone is traveling with their parents or with their children.
Parents. Okay, that is parts.
This is called parts. And siblings is like number of siblings, spouse. And like if you come at the bottom in the embarked, people embark from these 3 places: Queenstown, Southampton, and Chenpur. So from these 3 places, people embarked. Got it?
Right.
Now, what I'm going to do, I will quickly showcase that how it is happening, and I'm expecting that do not ask for the mathematical derivation. That's too early for us. I'm just going to, first of all, I'm going to read this data. So look here, I'm saying read.csv. I'm reading the data. So I read my data. Okay. And after that, I am performing some task. Okay. So I will explain you the graphical parts, that how it is happening. So let me do something. I'm doing some pre-processing. Oh, by mistake I hit this one. Library is there. ggplot. Perfect. Something is happening in the ggplot. Now, then I'm running some graph on the ggplot. I will show you. Look here. This plot is saying that those who traveled in class 1, class 2, class 3, this is what the x-axis is class, y-axis is the frequency. How many people survived and how many people didn't survive? If you look at this graph, what is your assessment? In which class majority of the people survived?
Class 1.
Class 1. So class 1 was the class of the rich people. Fine. That's what I feel, that the rich people were given more attention to survive. The other theory says that the class 1 was near to the life-saving boats. So they got life-saving boat and they departed. Okay. Now, are you getting that? I use ggplot. I'm saying training data. Aesthetic, I'm saying passenger class. I want to fill with survived. I wanted the geometry. X level is going to be passenger class. Y level is going to be count. Labels I want to fill with survived. That's what is coming. Did all we discuss in the previous discussions? Clear?
Yes. Yes.
Now, so this is how initially when we get the data, these are some types of analysis that we need to do. Then I will move to the other plotting. Okay. Wherein I did some very good quality of graphics using ggplot, but again, considering the time now, the second graph which I'm going to do, that is again mind-blowing graph. You will be getting a lot of stuff. So let me plot it. I hope it is going to work. Yeah, just wait. Great. So look here. In the one canvas, I plotted 3 differential graphs. 3 graphs are there. Okay. It is saying that this is first class, this is second class, this is third class. So in first class, those who survived, what was their gender? Like Mr., Mrs., others, Miss, Masters. Like for kids, we are using this master or a Miss, the unmarried, fine. So now, if you look at even in the first class, you will be realizing that majority of the teenage and females, they survived. So even in the first class, majority of the male didn't survive. Is that clear?
Yes.
In the second class, look here. In second class is also, in second class, majority of the male didn't survive, but the kids or the females, they were given a high priority to survive. In the third class, look here, same one. Majority of the male didn't survive, but even in the third class, almost 50% of the female didn't survive. So are you getting how clear these graphs are coming? Fine. In order to get these graphs at this level, we need to perform some tasks. And we didn't discuss about those tasks. That is the reason that I'm not explaining that what is happening. Okay. Then let me try. I think this graph does not work. Wait. That's the same one. Now, this is one type of the graph, one set of the graph, I would say. Then I move to second set of the graph, part 2, wherein I did something extra. Let me clean it. You'll be getting something new here. Then we are looking at the overall gender level, that is fine. That what percentage of male survived, what percentage of female survived at the overall level. So previous was aggregated, but now we are splitting all. Like if master is given, master is also considered under male. Fine. If miss is given, that is considered under female. So we are looking at gender level at the very high level. Okay. Then I think I did something else. Yes. Wait. Wow, this graph. If you want to see that age-wise, that how people survived in case of female in passenger class 1, in passenger class 2, in passenger class 3, in case of male passenger class 1, 2, 3, you can see, and red is indicator of non-survived, and this blue is indicator of survived. So you can see that in which age group people survived. Okay. Majority of young male in passenger class 3, they didn't survive. Similarly in passenger class 2. So I think hardly the young age segment male survived. So even you can look at the age wise. So that's what you remember initially I mentioned that you can split your canvas into multiple parts, and then you can see in each and every part that how it is happening. And it is too advanced for us at this stage, because before we land to this place, we need to perform certain tasks. Then only we can find this refined output. Is that clear? But I just wanted to showcase that how ggplot is useful. It is just explaining the capability, nothing else. The next plot. Wait. Yes, if you want to see an overall label, like if you look here, in passenger class 1, passenger class 2, passenger class 3, this is only done for the age group of 0 to 10 years. That's what happened. So see here, in passenger class 1, majority of the teenage, they survived. In passenger class 2, teenage, not less than 10 years, not teenage. In passenger class 2, the less than 10 years age people survive, but that's not happening in passenger class 3. Some survived, some didn't survive, but majority of the people didn't survive. Don't you find that they are the good insights?
Yes, right.
Now, similarly, the ggplot help us to get a lot of great insights. Okay, and it is helpful in doing your analysis. Next, see the next graph. What is happening? Now, here we are looking by miss. So those who are starting with miss, what is happening? So who survived? Who didn't? I don't know. This is 60 years. There are some unmarried. What I say, the old age lady. They survived. But if you look at here in the passenger class 3, the miss subtitle, the title, they didn't survive. So we are getting that at the different surname type title, what is happening? Because in your passenger list, name along with their salutation, their surname, their initials, everything is given. Fine. Then I have some 5-7 minutes before break, so I just wanted to showcase some good quality of graph. Wait, another one is coming. It is very sparse, but still you will be getting some idea. We are talking about master, others, MRS, that is Mr. in passenger class 1, passenger class 2. If you want to understand that what is happening, like passenger class 1, 2, this is how the numbers are. So you can understand that in different passenger class how things are behaving. You can look at that level as well in case that is required. Talking about the passenger class type, that how it is happening. It is not very useful, but yes, I tried it. And then the other graph. The similar one, not very useful, but yes, we need to run and see that what is happening. Not great insight. Wait, I think after that we'll have a break. I'm just waiting this graph to be up. Similar information it's giving that the family size and all, we are taking it. We are just trying to understand that what is happening with the different family size. Okay, here your XCC talking about the family size. So those who are in the small family size, they survived, but those which are having the bigger family size, you can see here, the chances for them to not survive is very high. Okay, reason being people waited that they will only go to the light boat if every member of their family is in the same boat. So that was another demand of the people. Fine. So these are some fine tuning which we can do using this graphic. And you must see that we are using facet. A lot of things are using here. We have statistics we are using, facet we are using, aesthetic we are using. So lot of things are coming. Now, if you want this code, I will share, but you must see that we are doing a lot of other processing in between, a lot of combining. We are performing some tasks, and that will be too early for you. So, considering that, I would suggest that go through what all discussion we had using Imatica slide, because that information is sufficient enough to give you some idea regarding ggplot. The one which I just demonstrated, that is at a too high level, and we do normally this kind of graphics when we work on certain technique. Like in this case, for the Titanic disaster, I was writing some query using random forest or the other XGBoost, different models. So before I land to that model, I did these all graphics to understand, to know about the data, not how my data look like. So now there was one question that why we do pre-processing, why we do ETL, or why we do visualization. Because initial phase, when you do some pre-processing, you do some visualization, you come to know about your data, that how your data is looking like. Getting it?
Okay.
Now, so that was the context using graphics. So going forward, in almost every technique, we'll do some graphics depending on the type of the data or depending on the algorithm requirement. But yes, this is going to be part and parcel of your every technique. That is fine.
Yes.
With that, can we have a break and then we'll meet after the break?
Sure.
Chinmay, if you can share the data, somebody can work on. Like I'm interested, so just look at it.
The data you this Titanic one?
Yes, yes.
I will share, but do not ask question regarding some processing which we are doing, which I have not.
Okay, sure. Sure.
Fine. So just consider.
Sure.
I will share. Just consider that we are doing something mathematically. You need to concentrate on the graphic part.
Sure.
Because that is too early for us. Even I explain, you won't be able to understand. That's why something is happening.
I got it.
I will share it. Fine.
Yeah, thanks.
So we are going to meet around 6:15. That's fine.
Yes.
Yeah, sure.
Okay.
Hi all.
Hi.
Hi. So just wanted to know how many people are back. Can you ping in the chat? Yes. I wanted to count the number. Almost 50% of the people has not yet come. So out of 37 numbers, there are 21. Yes, has happened. Just wait for another 1 or 2 minutes. I will share some homework, some assignment I will share for this topic as well. Now, I am going to start your next topic. And your next topic is statistics fundamental. So we had a lot of discussion about some basic data preparation, some visualization, some kind of understanding that how the data wrangling etc. happen. But now from here we are moving to the core statistics. Fine. So I hope you all people are ready.
Yes.
Fine.
Yes.
Just a moment. So there are 25 people. Okay. Oh, Durga Prasad, you ping some Titanic GitHub something. What is that? Is there any purpose for that? If you let us know. Durga Prasad, are you there? No, it seems he's not online. Okay. Once he's coming back, we'll talk about. Now we are going to talk about statistics, and I'm sure that you will enjoy this session. No coding, nothing. You have to simply listen it, and in case you want to make some note, you can make note. Okay. So first, we are going to talk about the basic concept. Okay. And in that basic concept, the first term comes the permutation combination. Have you heard this term? Permutation combination?
Yes.
Yes.
So what do you mean by permutation and what do you mean by combination?
It is to find the number of arrangements of words we can say or something else. Number of arrangements.
Okay. That's
Combination is how much combinations we can make.
Okay. So we are going to do some detailing. As I mentioned that it is going to be interesting. So let's say that you have 6 students, or I'm naming as A, B, C, D, E, F. Yes, 6 is too big. Let's make 5 only. There are 5 students I have, and I'm going to make a group of 2 people. Group of 2. Getting it?
20.
Now, oh, spelling group is wrong. GROUP. So I'm making a group of 2. So in how many ways I can make? AB, AC, AD, and AE. This is one way. BC, BD, BE, then CD, CE, and then D. These are number of groups I can make. 2 people group.
Yes.
Okay. Now at the same time, if I say, wherein if you say AB or you say BA, that is not making any sense, any difference. AB or BA both are same because these consist of the same 2 people group. Getting it? Is that clear?
Right.
Now, let's think it is not AB, it is like number 1, 2, 3, 4, 5, like this. Then if I make like 1, 2, 1, 3, 1, 4, 1, 5, okay, and then I can also make like 2, 1, 3, 1, 4, 1, 5, 1. Are you getting? These are different. 1, 2 is different than 2, 1.
Yes.
But but AB is same as BA, AC is same as CA. Getting it? So when it comes to selection that we are selecting, so the first part here is known as selection. Fine. And the second way which I'm explaining here, this is called arrange. Getting it? Now, so this is what the first part, like your selection, the way I mentioned, this is called combination. And the first part which I talk about, the arrange, that is called permutation.
Okay.
That is clear?
Yes.
Yes.
Now, I hope you have very clear idea that how permutation is different than combinations.
Yeah.
Now, that means if I talk about the numbers, now if I, let me open my notepad. So in our case, I have 5 element. So number of element was 5, and number of selection I wanted to do 2. Okay. So when I need to write permutation, okay. So in case of permutation, it is written as 5p2. Fine. In the case of combination, 5c2. Clear? And we write in the mathematics, so it is written mathematically like factorial. So mathematically, how to write it? So it is written like factorial 5 divided by factorial 5 minus 2. That is clear? In case of combination, it is written like factorial 5 divided by factorial 5 minus 2 into factorial 2. That's how it is written. Getting it? Like in our case, it is going to be factorial 5 divided by factorial 3, and this the bottom is going to be factorial 5 divided by factorial 3 multiply factorial 2. Is that clear? Now, so how we solve it? It is factorial 5 is written as 5 multiply 4 multiply 3 multiply 2 multiply 1. Either you write 1 or not. And factorial 3 is written as 3 multiply 2 multiply 1. So look here, this 3 is going to cut this 2 is going to cut this, and 1 of course it is going to be. So this is going to give us 20. 5 multiply 4, that is 20. In this case, in the bottom case, it is going to be 5 multiply 4 multiply 3 multiply 2 multiply 1 divided by 3 multiply 2 multiply 1, then again multiply 2 multiply 1. So this 3, 2, 1, it is going to cancel 3, 2, 1, and this 4 will be cancelled by this 2. So this is going to be 10. So look here, your number of combinations are going to be 10, wherein the number of arrangements are going to be 20. Fine? Let's count. How many are this? Are you getting this? The way I selected that suggested a selection, are you getting this at 10?
Yes.
Fine. That's what we just calculated, like 10. And if you go for a kind of your arrangement, then you will be getting that your arrangement is coming as 20. That's what the difference is between permutation and combination. So many people know that this is arrangement, this is selection, but if you ask them that what do you mean by selection and arrangement, they do not answer it properly. Now I hope you people understand that what is happening here.
Yes.
Perfect. Now that was the first understanding for permutation and combinations. Then we are going to talk about some basic concept about random variables, discrete variable, continuous. That we'll talk now. So from that perspective, we are going to talk about central tendency. Have you heard this term, central tendency?
Yes.
What do you mean by central tendency?
The generally like average of the data around that the other variables where it lies, we can measure that.
Okay. So you are saying it is kind of average of the data. Got it? Now,
Yes.
It's a mean, median, mode kind.
Yes, everything comes under the central tendency. So when I talk about the central tendency, these are primarily the measure of central tendencies: mean, median, and mode. Then we are going to talk about this mean, median, and mode. Okay. So first is going to be mean. What do you mean by mean? What is mean?
Average.
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 And what is median?
Middle value.
Middle value in the arranged order.
Yes.
When we arrange order, then we find
Central value. Okay. In arranged data. That is clear.
In ascending order.
Anything, ascending, descending, anything. Okay. Then what do you mean by mode?
Highest frequency number.
highest frequency in the data.
Mostly found.
You can say that the most occurred data or occurring data. Clear? We can call it?
Yes.
Now, I am going to change your understanding to a certain extent. I have a data which is like this data is like 1, 2, 2, 3, 3, 3, 4, 4, 5. Let's say that one series is given to me. If I sum up, it will be coming 27. Can you sum up and just confirm if my
Yes,
mathematics is
27.
correct?
Yes, 27.
It's 27. Okay. So sum is 27. How many records are there? Number of records?
9.
9. So if I talk about mean, your mean is going to be 27 by 9. That is 3.
Yes.
Now, my data is already in the sorted order. So there are 9 elements. So central element is going to be 3. Yes or no?
Yes.
So my median is also going to be 3. What about the mode? The number which is coming most. What is it? 3. So my all mean, median, mode, all are the 3 here. All are the same. So where is the difference between mean, median, mode?
But that inference is different in all cases.
In this data, all are same.
Yeah, please say loudly. Be close to your mic and then say so we can listen it.
In this data, all are same.
Yes, in this data, all are same. So be careful. What happened in the statistics when you are finding a situation wherein your mean is equal to median is equal to mode. Such data is called normal distributed data. This data is called normal. So in statistics, there is something called normal distribution, and that normal distribution considered that, or definition of the normal distribution is that your mean, median, mode all are going to be same or very close to each other. That is fine?
Yes.
Okay.
Yes.
And if I plot it in the graph, it looks like, wait, my pen tab is running here. So it looks like this, wherein this is going to be center, and this center is having mean, median, and mode. All three are falling at the same place. And this is what we call bell shape. You must have heard about bell shape. When you go for promotion, increment, and all to your boss say that, look, we are trying to follow the bell shape. So we are not sure that to how many people we can give the promotion. That happens?
The bell curve. Yes.
Bell curve. Okay. That is what the bell curve is. When your data is normally distributed, that is indicator, or that gives idea of the bell curve. So bell curve is coming from here only. Okay. Now, then going to slides. This is the mathematical definition of the mean is, we are summing up everything and dividing with number of records. Is the arithmetic average.
Yes.
Now, one calculation is done here. Just go through. That is fine.
Yes.
Yes.
Then coming to median. So according to theory, if you have odd number of events, you can find the central. But if you have even number of events, let's say that you have 10 records. So in that case, this is how median is calculated. So I would say that in this formula, there is one slight change I would suggest. This is not the correct formula. Okay. So what it says that I'm going to write the correct formula. You can rectify in your notebook. Okay. So let's say that in the same example, your data is having 1, 2, 2, 3, 3, 3, 4, 4, let's say 5, 5. So we are getting number of records. Number of record is going to be 10. Okay. So how median is calculated? It says that first you find n by 2. I'm getting it? And it is going to be 5. Then it says that do n by 2 plus 1. So this will be 6.
Mean of these two terms.
Right. So this is 6. So according to theory, it says that take the average of fifth and sixth element. Like 1, 2, 3, 4, 5. This is my fifth element, and this is my sixth element.
Again, it becomes 3.
Yeah, so it says that 3 plus 3 divided by 2, that is 3. So you can calculate in this way. Median, you can calculate that. Median is going to be 3. That is fine?
Okay.
Now, so I would suggest that the way I'm suggesting to do change into the equation. So your equation is going to look like this: n by 2 plus n by 2 plus 1, and then divided by 2. So This is what your correct way of writing the equation is. So what is happening in the slide? In slide it is written like, that is a small typo. In slide it is written like n by 2 plus n plus 1 by 2 and then divided by 2. That's how it's written. Fine, that is slightly wrong. It's not the correct way. So this this plus 1 is not in the numerator. It is coming as a standalone. So this is the correct equation. Just in case you want to make the rectification, you can do it. That is fine?
And no, slight query. N by 2 we are saying fine, 5, right?
N by 2 is 5, yes.
5, then n by 2 plus 1 is 6.
Correct.
Now, how come this is 3 plus 3 by 2?
So I'm talking
I could not understand.
This 5 and 6 is talking about the fifth and sixth element. Fine.
Yes, okay.
So this is
Taken for
first element, second, third, fourth, fifth.
Okay, okay. Right, got it. Values, right.
Value of that.
Okay.
Got it?
Got it, got it.
Okay. Now, this is what the equation is given, so you can do small modification. Now, look here. In this case, we are calculating median. Did you see what happened? It is same happening here.
Yes.
Fine. Then coming to mode. As I explained, that mode is the value which occurs the most, that is the most occurring element or the frequent occurring element. Is that clear?
Yeah.
Chinmaya, in mode, if two numbers occur same number times and it is the highest one.
It is called, that's what the second example is. So in second example, 2 and 7 both are coming 3 times. Okay.
Okay.
So that is called
So
by, that is called by model. So what happened in that case? Your graph look like this way. It looks like this. Getting it?
Okay.
Now, that's what it's saying. In this case, if you look at in the first example, 15 is coming twice, but in second example, 2 and 7 both are coming almost in the same frequency.
So we will consider both when we are doing some getting inside.
That's what we call it by model.
Okay.
Clear?
Yes.
Now, then coming to the next one. Then we're going to talk about something which is again equally important in terms of knowing the dispersion and all. So I will explain the meaning of dispersion. Okay. So there is one term which is called range. Okay. And we discuss about range in R as well. So if a series is given, so the difference between maximum and minimum, that's what we call range. Clear?
Yeah.
So that's what some write-up here for range is given. Like maximum minus minimum. I would say just go through, you will understand each and every bullet. Just try to understand. That's fine?
Yes.
Yes.
Now, this is what here in this example, a range is defined. Your data is given like 4, 6, 9, 3, 7. Your lowest value is 3 and highest value is 9. So range is coming as 6. That is 9 minus 3.
Uh, as we have seen in the last couple of examples, when there are two numbers value, so which one, I mean, how do we consider the range? The highest value, for example, there are two nines.
So anyone, it's only the number. It is not saying which number. Range only give you a numeric value.
Any highest value.
Yeah. That is clear?
Yes.
Range used in box plot.
A range using box plot, that is fine. But again, look here. In the box plot, if you take the difference of minimum and maximum, you are getting the range. Getting it? So it is given from the box plot perspective, but it is not necessary that it is going to be in box plot only. In any data, if something is given, if you want to know the difference between maximum to minimum, that's what the range is. Is that clear?
Chinmay, if in the range, if the highest value is like 1000, after 1000 is there, then we will remove that or we will consider it for range, like 1000 minus 4.
I would say at this stage, I will say that do not remove it, because we have not yet talked about the removals. So there are some process, we'll talk about that. But in nutshell, you need to remember that the data which you are considering, in that data, the difference of maximum and minimum is called range, be it outlier or be it not outlier.
Okay, sure.
Clear?
Yes. Yes.
Now, then we are going to talk about the variance. Have you heard this term variance?
Yes.
Now you tell me that what you mean by variance. Tell me, I'm just opening an Excel for some other work. You tell me what you mean by variance.
Deviation from actual.
Difference between two numbers.
Okay.
Variance is the deviation from an average.
Deviation from an again for variance, I did not. I do not want to listen deviation, because deviation is again another term. Okay, average is fine. So you can say that we calculate. You can use a simple explanation that the difference from the mean is indicator of the variance. That how far it is from the mean. Got it? So now I will tell you that how it is calculated and what is role for that. So I'm going to perform some task here, and you need to listen it, because if you listen properly, that will give you a very fair idea. Now, this says what the series I wrote. I'm calling it X. So be careful. Any series, like the way I'm saying here, series is denoted as X. Fine. And average of the series is denoted as X bar. That's what we discussed. Clear? Now, considering that understanding, we are going to calculate average. So I want to calculate average of this series. So I'm saying is equal to average, and I calculated it. My average is coming as 3. That's what my mean was. Then look what I'm doing. So I'm calling this average as X bar. Okay. Then I am calculating something which is called X minus X bar. Okay. That means is equal to 1 minus X bar is 3. Is that clear?
Yes.
Is it clear to everyone?
Yes.
Now, if I sum it up, like here, if I run the formula like sum from here to there, this will be 0. Are you getting why sum is coming as 0? This is one behavior, one property that we need to remember, that from average, if you take the difference of each and every data point and then you sum up, it is very close to 0. That's what we are getting. We are getting exactly here at 0. Is that clear?
Yes.
Now, in order to get rid of this scenario, it is suggested to do the squaring. Okay. So what are we going to do? We are doing the squaring. That means we are saying that let's square up. That means it's equal to this multiply itself. And then we are summing up. So look here. Now when I sum up, it is no more 0. Are you getting sum is coming as 12? Is that clear?
Yes.
Yeah, tell me.
Yes.
Are you saying is there any question?
Not yet.
No.
Okay. Now be careful. What all the sum we calculated here, how many records are there in my data? If I talk about n, that is number of records, we know that there are 9 records. Fine?
Yes.
So technically what we do, we say that this distance, the 12 is going to be divided by 9. And this is what the variance is. Getting it? So now if I write the mathematical formulation for the variance, it is calculated like, look here, x minus x bar square up sum up divided by n. That's what the variance is. That's what we are doing. Can you see that what exactly I did? I calculate x minus x bar, I square it up, I sum it up, and then dividing with number of records.
Yes.
Clear? Now, now, this is at the very high level nutshell. Here, what I'm saying. Now, the question comes that are you going to calculate for sample or you're going to calculate for population? So be careful. In statistics, we have something called sample and we have population. Getting it? In normal scenario, English letter is used for sample and Greek letters are used for population. Getting it? And now, from that perspective, your formula changes. If someone says that calculate the variance, like sample variance, then it is calculated the formula which I wrote, x minus x bar square up, sum up, and divided by n minus 1. Be careful, it is not n. For sample, we divide by n minus 1. But when it comes to population variance, it is written like x minus mu. That's what I mentioned in Greek letter. And then divided by upper n, the n which is written in the uppercase. So that is the reason that when I wrote here, I use small n. So small n is indicator that we are going to talk about sample. So in our case, the way I divided, it should not be divided by 9. It should be divided by 8. That is n minus 1. So that this is a small difference between the sample variance and the population variance. That in sample variance, we divide by n minus 1, wherein in the population variance, we divide by the n. Is that clear?
Yes.
I hope it is clear to everyone.
Yes. In population variance, it is not a sum, right?
Which one?
It's just x minus mu. In population variance.
Oh, in the population.
I don't see a sum.
No, this is again a
This is
sum. Everything is sum.
Chinmay, in sample variance, why we are reducing 1 in the n value? Because if the sample is n, it should be n only.
Okay, so there is something called degree of freedom. So technically, this term, this n, which is written here, the name for that is degree of freedom. Getting it? Now,
okay.
According to statistics, I will explain you what is degree of freedom. So let's say that you have 5 shirts. Very basic example. You have 5 shirts which you use for office wear. And on Sunday evening, you got your all 5 shirts ready. That is cleaned, ironed, everything. Now on Monday, though we are in the lockdown, we are all working from home. But think about the office scenario. So on Monday, let's say that you are planning to go to office. So how many options you have to select the shirt?
5.
5. On Tuesday.
Yes.
On Tuesday, how many options?
It will decrease 1, 4.
4. Wednesday.
3.
Thursday.
2.
What about Friday?
No option, only 1 is left.
Got it? That means if you have 5 objects, then the degree of freedom, that is the selection criteria, you have 5 minus 1. You can only select in the 4 instances, not in all 5 instances. Getting it?
Okay. Okay.
That is the reason that it is divided by n minus 1.
Okay. And for population, we are not doing because it's a very large value.
It's very large. We never know that how big it is.
Okay, got it.
So that is the mathematical reason that why in the sample we divide by n minus 1, but in the population by n. That is clear?
Yes. But for our general calculation, why we are doing that? Like for generally in our classes like 10, 12 or basic education, we are using n only in that.
I would say there everything is considered like population. People never talk about.
Okay. Okay, got it. Yeah, thanks.
Fine. Now, with that, I hope it is clear to everyone. Is there any question? Is there any question so far?
Chinmay, just for my understanding, while we are doing this variance, we are doing x minus x bar to the power of 2. One reason is that we are doing to the power of 2 to negate these negative numbers.
Correct.
To neutralize that.
Correct.
Right.
Correct.
But the value is also increasing.
Okay, so I'm coming to that. I will come to that. So when we calculate the variance, like in this case, I'm going to divide by 8. So I'm saying dividing by 8. Got it? This is the variance. There is something called standard deviation. Standard deviation. Okay. Which is under root of the variance. Getting it? So if I say is equal to SQRT, that is square root of this one, that is what your standard deviation is. So if you want things to be in the same unit, and that's a very valid question, if you want things to be in the same unit, use standard deviation.
Right.
Clear?
Oh, Chinmay, could you repeat
Right.
that once?
Standard deviation?
Yep.
Now, his question was that in this case, 12 is, let's say that x is height. Height is given in centimeter. Okay? I square it up. Now, this is becoming in centimeter square. Getting it? It is coming in centimeter square. So the value of the variance which I am getting, that is again coming into centimeter square. My original data is given in centimeter, but variance is coming in centimeter square.
Yep.
So in order to make it centimeter, if I take the under root of this, it will become centimeter.
Mm-hmm.
Got it?
Okay.
That is what the standard deviation is. So standard deviation is under root of variance, and technically why we do it, reason being standard deviation help us to bring our data in the same unit in which we calculated.
Okay. Got it.
That is clear? Now, that's what given here. Today attendance is very low. I don't know why. There are only 34 people. Almost 1/3 of the class is missing.
It is maybe because of the festival tomorrow.
Tomorrow is festival?
Yes.
Yeah, this is
What
a
festival?
Raksha Bandhan festival, maybe.
Yeah, Rakhi is there.
Oh.
Chinmay, any practical application where variance is like being considered? Any one is simplest example.
So can you repeat once again what you're saying?
Any practical simple example where variance is like considered for knowing some detail of the data.
Okay. So the share price example. Okay. Let's say that you have two share. One is, let's say, share A and other is share B. Okay. Now.
Okay.
And you have 10 days record, like day 1, day 2, likewise. Okay. Let's say you have 10 days. Share A has price like, let's say 20 rupees day 1, 22 rupees day 2, 90 rupees day 3, 24 rupees day 4, 23 rupees, 20 rupees, then 19 rupees, then let's say 18 rupees, then 24 rupees, and let's say again 20 rupees. This is one share. Other share is again started with 20 rupees, and next day it went to 25 rupees. Next day again it comes to 21 rupees. Next day it is going to 15 rupees. Then after 15 rupees it is jumping like 28 rupees. Something happened. Then 21 rupees, 27 rupees, then let's say 16 rupees, 18 rupees, and let's say then to some day it is going 30 rupees. Let's say that two shares you have. This is B is supposed to come here. And this is the historical last 10 days trend. And you are going to invest in the share. Okay? And you want to invest in the share which is a kind of stable, not very up and down. So lower the variance or standard deviation, anything. So I'm saying variance. Lower the variance, more stable the numbers are. Getting it? And reverse.
Okay.
Higher the variance, the less stable the numbers are. Got it? So if you calculate the variance, I'm not sure if there any package in Excel. I'd say there is a package. If you calculate the variance, here in the first case variance is coming 4.77. In second case variance is coming like 26.77. Did you see how big the difference is coming?
Yes.
So the second share B is more volatile. Fine. If you are very risk averse, or let's say that you want to invest in risky share, so maybe this will be a good day for you, wherein you purchase share of 15 rupees, next day it is 28 rupees, you sold it. Getting? At the same time, if you consider this time frame, this is very bad for you. You purchase of 21 rupees, next day it is 15 rupees. Getting it?
Yeah. Yes.
But in the share A, it is not happening. In share A is more or less, it is very close to, it is not too volatile.
Correct.
Getting it? Like in Indian cricket, Ashish Nehra, I hope you people have seen his bowling, Ashish Nehra. Fine?
Yes.
Sometimes three run in over, and sometimes 20 run in over. Do you think as a captain I should trust him?
No.
In match winning situation, risk when a captain is willing to take risk, he can trust.
Again, I'm saying that you have two players, two bowlers. Okay, look here. One bowler, bowler A, and bowler B. Bowler A is, let's say, average of bowler A is 5 run. Average of bowler B is, let's say, 3 runs. Okay, this average. But standard deviation of bowler A is, let's say, 2, wherein standard deviation of bowler 2 is 5. I will not trust bowler B because I never know. Sometimes he will give 8 runs, sometimes he will give 0 runs. So it all depends. Okay, that let's say that you are in the last over of the match, and your opponent team needs 9 runs to win the match. Okay, and you have two bowlers like this, A and B. Okay, or let's say that they are going to get, wait, let me slightly increase it, 5 to 7, I'm saying 1, and this is, okay, and this is, let's say 8. I just change number. Okay, so let's say that the scenario, the opponent team need 8 runs to win the match, and you have two bowlers like bowler A and bowler B. Okay, to whom should you send? Tell me. This bowler B is not reliable because there may be situation today is bad day for him. You will lose the match, but bowler A is very consistent. Got it?
Yes.
Can we plot the variance on the graph as we have seen in earlier graph?
No,
Can we plot the variance?
No, variance is a single point. You cannot plot in the graph. Of the entire series, it's a single point.
So how do we take a reference for this?
It's only the value, looking at the numbers, looking at the value.
Because it is not also a percentage kind of a thing. For example, you are saying that variance of 4.77. Maybe we cannot consider it as 4.7%.
No, it's not.
Because it's an absolute number.
It's all relative. So let's say that you have two numbers, you have two share prices, and you need to decide out of these two which one is best. So it is all comparative.
Yes. Yes. Only say, for example, when we are saying variance of 4.77, and for example, the average price or the average of the share, can we go back to the last earlier this thing Excel sheet?
Yeah.
Yes. Now, if we can take the average of A and B, please. Now, yes. In order to understand, like say for example, 20.9 is an average and variance is 4.77. Maybe which is a fair reference point in terms of telling you that variance is around, say maybe around 25%. Whereas in
do not interpolate into percentage. Variance is never represented in percentage. You can say that this is what the magnitude of deviation is. Okay, but do not You can say in percentage, but that is not the ideal language to interpret.
Or in other words, can we say that we can take variance plus minus 4.77? Say the highest can be 20.9 plus 4.7, or minimum side can be 20.9 minus 4.77. Can we also interpret in that fashion?
No, if that is the case,
No.
then let me add it. I'm saying this plus this. You are saying highest. So maybe in this case, there is one number 24 here, the highest.
Yes.
It is coming close to that, but that is not going to happen in the second case. Look here, in second case 48.
Yes.
None of your data points
Right.
are 48.
Right.
So we can't say that is not the logical way to interpret.
Chinmay, if we can convert a variance into standard deviation and then try to take percentage along with the mean.
I would say that any percentage, if you are going to take it up, that is not the ideal way to interpret it. You're saying that just take its square root, okay, and convert into standard deviation and then do it. You can
in
take
percentage terms.
Yeah, you can take it up, but that is not the ideal way to represent. Variance or standard deviation is always represented in terms of absolute number. And we always compare looking at these two values. Like if you are comparing with standard deviation, so look at these two values and say that the second series is more volatile. Almost here you can say that the second series in terms of magnitude is almost double volatile than the first series.
Can you repeat, please? Volatile in terms of double what?
Volatile means unstable. So like here in the second.
Understood.
Yes, in the second series, your standard deviation is coming as 5, where in the first series it's coming like 2.18. So we can say that the magnitude of the second series is almost double of the magnitude of the first series. But do not interpret in terms of percentage. That's a wrong interpretation.
Understood. But in terms of if you go to the various part, it is almost 5 times, 4.77 into 26. So which is 5 times variance, and standard deviation is 2.5 times.
Right.
Right. I mean 26.7. Yes.
Yeah.
Yeah. So okay, I will read more about this myself and then try to understand. I think this is fair enough. Got it.
So, but variance standard deviation is never represented in terms of percentage.
Understood. Yeah. Percentage or yes.
That is a misleading.
Chinmay, which one is used most, variance or standard deviation? There may be point in your experience, like one place where you have to.
Standard deviation.
Sorry.
Standard deviation is
used most.
Yes. And the reason is the better benefit which is associated with standard deviation. It gives you the number which is in the same unit in which data is collected.
Sure. Yeah.
And 6 sigma and all that is coming from standard deviation. Sigma is standard deviation. Getting it?
Yeah.
So standard deviation is widely used in the industry. Got it?
Yes.
Now this is what the variance is given. Then look at this.
Sorry, sir. Just one more thing which came into my mind, because see, while production lines, we see, for example, there is a packaging unit, right? And 10,000 cups are being produced, say, on the line per hour.
Right.
So generally, the average, say, for example, we used to do it in. I do remember in my earlier organization, wherein you used to understand what is the variance in terms of average weight. Say, for example, the standard weight is around 50 grams per cup, right? So we used to track it should not go beyond, say, 48 grams, and on a higher side, should not go beyond 52 grams.
Right.
So for that, we used to generally measure the data record the data for this entire unit, and try to understand what was the variance for this thing.
So that's what.
So larger is the variance, the lower is the efficiency of the machine. So we used to monitor that this thing. So
that's what we are going to talk. That is the 6 sigma concept. So we'll talk about it. Okay. that will come. So the moment you are saying like 18 or 22, that is what the lower bound and upper bound is. We'll talk about that.
Okay.
We'll talk about that will come. And those numbers that you are saying, that is technically the standard deviation. That is not the variance. The moment we took into the lower bound, upper bound, that is the standard deviation number, which is under root of your variance. I will explain about that. So there are some magical numbers, and those magical numbers will come.
Okay.
Fine?
Right.
And this 3 standard deviation left and right. So 3 plus 3 is 6. That's what the 6 sigma is. So I will explain about the 6 sigma as well.
Okay.
That will come.
Right.
Now, look at this data. And tell me, in first case and second case, what is happening? In first case, your all data points are having same value. 12, 12, 12, 12, 12. What will be the variance?
Nil.
Zero.
No variance.
0.
Yes.
But in the second case, you have the same story, 12, 12, 12, but one point is very big. That is 13013. Did you see the variance? How big the variance is?
Yes.
Fine. That means in your entire series, if there is a single outlier destabilize everything. Your variance goes high, your standard deviation goes high, and you are left nowhere because your data is not good. Is that clear?
Yes.
Then I explained about the standard deviation. This is technically under root of variance, and look here. In the denominator, it is given n minus 1, and n is given smaller n, and x bar is given it's not mu. So this is known as the sample standard deviation.
Chinmay, in R and Excel sheet, whether they are using n or n minus 1 for calculating standard deviation?
I would say that if you use simply the formula, so there is a formula to calculate standard deviation. There it calculates it, consider n. But if you are calculating manually, you need to do n minus 1. And the way we do in R, R understand both n and n minus 1. You need to say that you are going to
So
do
there, which one? Okay.
or you are going to do
Excel, there is no, in Excel there is no option that we can segregate.
Excel is not meant for the majority of the statistical understanding. Getting it?
Okay. Okay. Yeah.
There you need to pass manually. You can do almost everything, but in that case, you need to pass it. You need to say that this is what we are going to do. That is fine?
Yes.
Now, once that is done, then we are moving to the next part. So that's what I explain here, that in terms of calculating the standard deviation, be careful. It is sample or population. So in formula, you will come to know if it is talking about x bar, it is sample. At the same time, if in the denominator it is n minus 1, it's sample. Else it is going to be population. Now, in the box plot part, I explained about interquartile range. We discussed about this?
Yes, sir.
This is Q3 minus Q1. That's what I explained.
Yeah.
Yes.
And sometimes people talk about the semi-interquartile range. So this is Q3 minus Q1. If you divide by 2, this is called the semi-interquartile range. There are very rare use of semi-interquartile range. That is good for knowledge. But in statistics or even in the box plot, we use interquartile range only. It is good to know semi-interquartile range, but there is no any application going forward. We are not going to use anywhere semi-interquartile range. Now, the next term is talking about the coefficient of variation. So now, let's understand that why we are talking so many things. as I mentioned, that statistics is such a subject wherein we cannot rely on a single parameter. On a single value, we cannot rely. It is like medical test, wherein if a patient is going to a doctor, doctors suggest multiple tests, that get the blood test, get some BP test, lot of tests they suggest. Because one test may not give you the complete picture. The moment you have the report of the multiple tests, you can well figure out that what the issue is. And that is the reason that coefficient of variation is the another information about your data, and it is calculated like standard deviation divided by mean. That's how we calculate it. That is fine.
Yeah, it is fine.
Yeah, yes, and this can be converted into percentage at times when it is used.
You can, but I would again suggest do not go into the percentage. Now, understand the impact. That's how the impact is going to be.
Sure.
Now, look here. This graph will give you very clear picture. Let's say that I have one distribution which is like this, and I have another distribution which is like this. If I talk about mean, mean is going to be the same. Getting it? But in both the cases, I will have my different standard deviation. The upper graph, bigger graph, will have the bigger standard deviation. The inside graph will have the smaller standard deviation. I hope you people can figure out. Now, it's at times it so happen that you are going to get two data wherein the standard deviation of both the data points are same. Now, then question comes, the challenge comes that out of these two, which one is better? Now, I will put you in fix. So you will be getting, I'm going to write another scenario. Just try to understand. That will give you idea. I have a series like 1, 2, 2, 3, 3, 3, 4, 4, 5. And another series is 1, 3, 3, 3, 5. If you calculate in first series, your mean, your median, and your mode, all are 3. In second series also, your mean, median, and mode, all are 3. Can you figure out?
Yes.
Yes.
If that is the scenario, then if you are going to consider only mean, median, mode, you will say both are same. Fine?
Yes.
But both are not same. If you calculate the variance in series 1, like, or you calculate standard deviation here and standard deviation here, both standard deviations are not going to be the same.
Can we plot this figure on a bell graph?
So if you plot on the bell curve, both will look like normal.
But at least as you have shown, it will take a different shape.
Your shape will be normal only. That's what I'm saying. That when you plot the histogram, your shape will look like normal, because in center you are getting the more number of instances.
But it's not, but the graph will not superimpose each other.
It will
there
not
will be variation in terms.
It will not superimpose. That's what I'm saying, that
Right.
in case of the first graph, so if I plot like your first graph, wherein first graph will come like this, and second graph will, in terms of standard deviation, this will come like this, because this graph will have higher standard deviation, and this will have the lower standard deviation. So this is with 9 points, and this is with 5 points.
Both only parabola. eventually.
Both will be like your bell curve only.
So in graph, can we go back slightly below?
Yeah.
If you see, for example, we have taken mean, median, mode as a standard this thing
Right.
in the graph,
Right.
central line. So
Right.
where do we point? Can we also point out where the SD is, standard deviation is in the graph?
No, in graph, you cannot point the standard deviation. Looking at the spread of the graph, you can figure out that which graph is having
Figure
higher
out.
standard deviation.
Spread from on the x-axis.
X-axis, how big the spread is.
Okay.
The reason being,
Okay.
from this, you looking at the spread, you can figure out.
Right.
Fine.
Fine.
Now, if I write same in Excel, like if I quickly do it, 1, 2, 2, 3, 3, 3, 4, 4, 5, and then I'm writing another one, 1, 3, 3, 3, 5, and calculating standard deviation here, or I'm not sure. Standard deviation, there is a function. If I do it, it is giving standard deviation like this one. If I calculate here, standard deviation on this one, see what is happening. Are you getting this one is giving higher standard deviation?
Yes.
Fine. So that when you plot, though data points are very small, very less, we can't plot in using R or anything. But yes,
right.
Wider the spread, you can figure out what is happening.
Okay.
Clear?
Right. Clear.
Now, so you just saw that there are certain cases wherein mean median mode alone cannot give you the best answer. So in that case, we need to take help of standard deviation or variance. Getting it? There are other instances wherein the standard deviation of the two series are same. And now you need to take decision. Then we talk about coefficient of variation. We divide by the mean and then see that which number is less. Clear?
Right.
Yes.
Now, then we are going to talk about the shape of dispersion or the lack of symmetricity. That's what we call. So, as I explained, that the moment your data look like bell curve, that is indicator of normal distribution. Got it? Now, if your data is not having bell shape, so that is known as asymmetric data, or a data is known as skewed. So skewness is a kind of asymmetric information, a data which is not symmetrical. Now, this type of graph wherein your skewness is coming left side, skewness, that is thin area. So if the thin area is coming in left side, this is called left skewed. Getting it? Okay. Let me do something in R that will I will showcase. I am writing some data saying x is equal to 2, 2, 2, 3, 3, 3, 3, 3, 4, 4, 4, 5, 5, 6. I run it. And then calculating box plot on x. Object X is not found. So this is upper X. Now, did you see what is happening here in this data? Are you getting where median is coming? At the bottom side? It's coming here?
Where the frequency is.
Right. Now, then let me do the histogram. Histogram on X. You must have seen what is happening. This data is where the skewness is in this data. It is skewed in the
Right
left side
side.
or right side?
Right side. Right side. This is on the right side.
Perfect. That's what the skewed data is. So you're getting that skewness in the right side. Now, be careful. Again, I'm just reiterating. If you go in the box plot is also saying the same story. It is saying that your 50% data is down this and 50% data is having that much of the coverage. That means this area, upper side area is skewed. So if this thick line is falling under the center, then that is normal distribution. If it is falling downside the center, that is indicator of the right skewed. If it is falling on the upside of the center, that is indicator of the left skewed. Is that clear?
Yes.
Now, that's what the skewness is. So, wait. Then I'm going to create another data. I'm saying is equal to y is equal to let's say 7 minus x. Okay, and then I'm doing box plot of y. Did you see what happened here? This went up, the thick part.
Yes.
And now look how your y is looking like. If I call y, you will be getting what is happening in your data. Did you see? The less frequencies are falling on the right side. Left side is so that's how you can figure out about the left skewed, right skewed. Looking at the graph, or even you do the like histogram. Wait, I think I need to work on the data. It's not giving too accurate, but again, it is going right side. I need to rearrange, like I need to write like I need to reverse it. That's not in a very proper way, but here you are getting that information. That's how it is shifting. So looking at the graph, you can figure out it's a left skewed or it's a right skewed. That's what it is saying. Okay. And
one question here.
Yeah.
So skewness, we are going to mainly depend on median or mean?
All it's on both. So in the left skewed data, look here, your median is falling here and mean is falling here. So on the x-axis, the value of median is more than the value of mean. So if the value of median is more than the value of mean, that is indicator of left skewed. Is that clear?
Okay.
Is that clear?
Yes, sir, it's clear.
Yes. Okay. Look at this data. That's what it's saying. Left side is your left skewed, the green is right skewed, and central is the normal distribution. That is called symmetrical distribution. Symmetrical, that means to the center, left and right, both are similar.
Chinmay, is there a way to remove this skewness and then use it as a normal distribution to process?
Yes, there are ways. So there are treatment that will learn that how to treat the data to bring it normally distributed.
Okay.
But I think this is clear.
Chinmay, in this graph, we can clearly see that the mode is the central one. I mean, the highest one. But how did we actually place the median and the mean here? How do we place it in the graph
You
without knowing the
calculate,
point?
like I will tell you that how it happens. In your data itself, like the first data, okay? If I simply run the summary of X, that will give you all the informations.
Okay, it is through calculation which we get that.
Can you repeat once again?
It is through calculation that we get that. The formulas that we have.
Yeah, it's through calculation. Clear?
Yep.
Now, then there is something which is very important that is Carl-Pearson coefficient of skewness. So when we get the data, like we have mean information and we have mode information, how can we figure out? So I would say that in terms of knowing the skewness, mean and mode are the most useful. Median does not carry a lot of information. So Carl-Pearson suggested that you calculate the difference between mean and mode, multiply that by 3, and then divide by standard deviation. That's what the formula is saying. Mean minus mode multiplied by 3 and divided by the standard deviation. Fine? And this is known as SK. So SK is for here, the K is coming for Carl-Pearson. Now, according to his theory, if the SK value is going to be less than 0, then your data is negatively skewed. If it is close to 0, then your data is normally distributed, not skewed. If your SK value is greater than 0, then that is the positively skewed. That is known as the right skewed. So this is how your system calculates and give you the information it is negative or positive. Is that clear?
Yes.
Also, we can use like median minus mean if it is greater than 0, then it is left skewed. As per the graph, mean was before the median.
You can say there is nothing wrong in saying that, but the Carl-Pearson theory, that is what people use widely, and that is in terms of the precision or in terms of getting the information, that is very solid or it's very sound. So I would suggest to use this.
Okay. Sure.
Now, once that is done, then I am moving to the next slide. Now, then we are talking about something called kurtosis. Okay. So let's understand about the kurtosis. Let's say that you have one data. This is your normal, let's say your normal distributed data is. And there is another which is again a kind of normal. And there is other which is again kind of normal. Let's say that there are 3 distributions. Getting it? If you look into the first distribution, the first one, this one, this peak is very sharp. It's very sharp peak. Or if you see here, the top is very sharp. The third one, the top is kind of flat. The second one is happening when the top is neither too sharp nor too flat. Fine. Depending on this topness, that what is the how is the top, we define that these all three are normally distributed. So in terms of bell shape, I would say not normally distributed. These all three are having the bell shape. But if you look at those tops, that's how the name is given. So the first one, wherein top is very sharp, that is called leptokurtic. Fine. The third scenario, wherein top is very flat, that is called platykurtic. And the second one, wherein it is neither very sharp, neither very flat, that is called mesokurtic. So technically, the mesokurtic is something which is good for the analysis. Leptokurtic and platykurtic is not too good. Like I'm saying, a healthy person. Healthy may be a person who is of 40 kg, and second person who is of 60 kg, another person, the third person who is of 80 kg. I am not looking for very thin person, nor I am looking for very heavy person. So in my case, 60, 70, 65, 70 kg is good for healthiness. Getting that?
You repeat, Chinmay.
I'm saying that we are talking about the healthy people. Fine. So healthy may be a thin person may also be healthy. A fat person may also be healthy. At the same time, a person who is average weight is also healthy. So if you define that out of these all three healthy, which one is the ideal healthy? So I would say that the middle one.
Middle one.
Neither too thin nor too fat. Getting it?
Yes.
That's what it is saying. So the first is very thin, the third is very fat, and in between is neither too thin nor too fat.
Okay.
Got it? Now, so this is how the names are given: leptokurtic, mesokurtic, platykurtic. All three are bell shaped. It is not skewed. Now, so those were certain distributions that were discussed, and we come to know that what is variance, then standard deviation, the coefficient of variation, then skewness, kurtosis. So those all talks about the shape of your data, that what is the shape. Now, then we are going to talk about probability, and probability is technically a very interesting subject. Do you feel so? Probability very interesting?
Yes.
Okay.
Yes.
It is. And the bad part with probability is that your answer is smaller than your question. So your questions are bigger, answer is smaller. So if a probability question is given in 4 lines, you may be getting answer in 2 lines, unlike other questions. Clear?
Yes.
Right.
Now, that's what the best part is, that you need to use a lot of words to explain, to ask your say. Now you tell me what you mean by probability. I just want to know the common opinion.
Chance of
It's like
happening.
chance.
Yeah, please you go ahead.
It's like chance of happening events in a total number of events that has happened.
Total number of outcomes.
Yeah, so you can say it's a chance.
Total number of outcomes.
So you can say it's a chance of happening something.
Yeah.
Clear? Someone else was trying to say something. Do you have some other opinion?
Same thing.
Okay.
The outcome of happening something in terms of yes or no.
Now, so here we are measuring that, we are trying to know that what is probability. So according to theory, probability is the occurrence of a particular outcome. Like let's say that you are throwing a dice and you are trying to know that what is the probability of getting 4. So the probability is the occurrence of a particular outcome by measuring its significance in a daily problem. That's what we try to understand. Okay, like in your daily life, there are wherein something is happening in a normal scenario. Let's say that you are going to purchase milk and you are trying to get the calculate. You're calculating the probability that what is the probability that today you will get the desired milk. That means the milk product or the milk quality you are expecting, you will be getting it. Or you are throwing a dice and trying to know that what is the probability of getting 4 or 6. That's what's saying here. So it is required to know about inferences of a certain conclusion. Again, this is a textual language. Inference that if something is going to happen, then if something is coming, then how are you going to get the conclusion out of that? Like probability of getting cloud black. Okay. Now let's say that you got that cloud is black. Then what inference you are going to get from there? Fine. This black is it's carrying some water, that's why it's black, or black due to pollution. It is carrying a lot of polluted air. So that's what the inference, what the conclusion you are getting out of that, that is equally important. Getting it? Now, then saying that the statistics and probability are also important is that the field of the statistics provide many tools to understand underlying data, draw certain inferences from the data, and make some predictions or make some conclusion. We'll talk about it, that what kind of conclusions are made. Now, here it's saying that figuring out what probability means. So there are many things written. There are 5 bullets. I would suggest go through and try to understand what these 5 bullets are saying.
That's clear.
Clear?
This is clear.
Done. Then in the probability, there is one type of event that is known as mutually exclusive event. Mutually exclusive. That means if one is happening, other is not happening. Like if you throw a dice, so if head is coming, then tail is not going to come. And those types of events are called mutually exclusive. Clear?
Yes.
Yes.
Now, then in the mutually exclusive, it may be equally likely or it may not be equally likely. Like in the case of a coin, you are flipping a coin, getting head or getting tail is mutually exclusive. If head is coming, tail is not coming. Okay. If the probability of getting head and tail both are the same, then it is called equally likely events. Fine. Either head will come or either tail will come. Fine. But if your coin is biased, that is one side is heavy with respect to other side, then in majority of the time you will be getting one particular type. Okay. Or if your coin is like coin of movie Sole, fine. So in that case, you will be getting only one side.
Yes.
Now, so the moment we talk about equally likely events, so there we those events are considered wherein the chances of coming each and every number is equally the same. This is called equally likely event. Like in case of dice, 6-face dice, or in case of coin, normal coin, getting any number is same. That is called equally likely event. Now, then we are going to talk about independent events. Okay. Now, be careful. There are, as I mentioned, that statistics is slightly confusing. It's a very easy subject, but slightly confusing. We are going to talk about independent events. So for independent events, I need to narrate some story. Without story, it is slightly tough. So let's say that you have a pot here. In this pot, you have, let's say, 4 black diamonds and 3, let's say, red diamonds. That means in total you have 7 items. So I'm saying n is equal to 7, black is equal to 4, and red is equal to 3. That's fine. Now, in this case, what is the probability of getting black in a draw? So there are 4 black and there are total elements are 7. So out of these 4, if any of the 4 is coming, you are getting this.
Yes.
Now, then calculating probability of getting red is going to be
3 of 7.
3 by 7.
3 by 7. That is clear.
Yes.
Now, let's say that in the first pick, you put your hand inside and luckily you got a black. But getting it? And now you are taking this black out. So now this black is coming here and so this black is no more here. So from here you have taken there. Clear? Now if that is the scenario, then in the second draw, this first draw is fine. Probability in getting in the first draw. Now then we are going to calculate probability in the second draw of getting the black. So what is the probability now?
3 of 6.
3 by 6?
3 of 6.
Getting it?
50-50%.
Yeah, that means your second draw probability is depending on what happened in the first draw. Okay? In first draw, if that is not the black ball, let's say it is red ball, getting it? Then, and you are taking red out, then you are left with 4 black and 6 total. So now your probability will be like in the second draw, it will be 4 by 6. Yes or no?
Yes, yes.
Now, so those events wherein your second draw is function of the first draw, what happened in the first draw, then you are deciding, those events are called dependent event. Independent. Fine. Your second draw is function of first. But I am talking about another scenario wherein you are not taking this black out. Okay? You are not taking this black out here. This is not taken here. Okay? You just put your hand, you got a black, and you just counted. Okay, in the first pick, like in the first pick, you get black. Then you are again putting black into the bowl, and then you are going to do the second pick. So again, in second pick you have 4 black and 3 red, so your probability is going to be the same. In second pick also you are going to be 4 by 7 because you put your diamond back into the bowl.
Yes.
If that is the scenario, first scenario, then those are called independent event. Fine. So dependent independent is something which is decided that the moment you are going to repeat the task is the probability of the second time is changing or varying depending on the first one, or that is not changing or varying. If it is changing or varying, then that is dependent. If that is not changing or varying, then that is independent. That is clear?
Yes.
Now, here, it is saying that you are taking a ball, red, and again putting back. And you are making everything like independent. Now, read it. What all is given in the slide, you will understand. Is that clear?
Yes.
Yes.
Now, next we are going to talk about some probability equation, and that is on the non-mutually event. So the events which are not mutually exclusive, non-mutually exclusive. Yeah.
Can just for a while. We have taken independent probability and dependent probability, right?
Right.
In real life situation, if we try to correlate, say for example, withdrawing money from an ATM or depositing money in a bank, these are the dependent event. For example, somebody has already drawn X amount of rupees or denomination. This is if you are going to the ATM, then your probability will have an impact on the earlier event. Is it correct?
I would say that again, it is the perspective that in which way you are thinking.
See, for example, there are 1 lakh rupee in an ATM, right? Now somebody draws 10,000 rupees, right? So now the next event which is happening is 19,000.
Correct.
Or if you are considering it as an independent event because you are drawing money,
in that case, it is dependent event.
And there are another possibility. Then you are saying that there is a 90,000 rupees and you are drawing money. It has no relationship with an earlier event.
Right.
Because most of the time, while going through probability, we generally take an example of balls, coins, and dice. But in real life situation, we are not able to correlate and understand how does this real probability works. For example, if you are saying independent in a real life situation event, I'm not able to find out.
The independent one?
Yes, sir.
Okay. So now in the real life scenario, when we talk about the independent, that how things are happening. Okay. Think about a racing car. This your entire what I say this one the rental car which work, Zoom car, etc. Okay. You are taking one car, getting it. You spend your time, then you are giving back to the vendor, service provider. Getting it? And tomorrow, let's say that you are very, very particular saying that you are looking for some SUV car. And let's say today you got one SUV and in the evening you deposited. Tomorrow again you are looking for SUV. Getting it? Maybe possibility that you are going to get the same car.
Right.
Got it?
So that is got it.
That is the one scenario. Second, shopping bag or the shopping basket when we go to the retail store. We take the shopping bag or basket, we do the shopping, again we put back to the entire lot. Getting it?
Right. Shopping basket. Yes. We keep it back at there. So probability of getting remains same. Yes. If there are 100, you can say trolleys. So next time you go, again there is 100 trolleys. The probability may be 1 by 100.
Right.
Every time you go to the outlet. Understood. Thanks.
So there are many instances, and why we talk about this coin or the playing cards or dice, because those are easy to understand. But yes, going forward, we'll talk about the real life scenario, that where it is used. We'll talk about some distributions, that like Poisson distribution, what happened, binomial distribution, what happens, what kind of probability is taken care.
Right.
So where all you are doing something and post your work, you are going to put back. Okay?
Yes.
Like many examples.
Right. Understood.
Let's say that you are going to some places wherein people conduct some adventure event. Or let's say you are going for bowling. Those bowling we do. Wherein we need to find the shoes. We wear those special shoes before you throw the ball.
Right.
You are getting the shoes, you are performing your task. After completion of task, you are submitting shoes, coming back. Maybe tomorrow if you go, you will be getting the same shoes.
Right. Similarly, going to the library, reading the book and putting it back. Yes. Again, next day you go, you probably understood now. Absolutely clear.
Fine. Now, with that, we are. There's another equation given here, the probability equation, that we'll talk in next class because now we are on the top of the hours. So we'll start in next class. Fine?
Yes, sir. Fine.
I think we completed. This is your second week, correct?
Yeah.
Second week we completed. I hope you people are learning something.
Yes, sir.
That is quite interesting.
So, Chinmay, one request to you, please share some assignment or some other stuff for reading and practice purpose.
For that ggplot and visualization, correct?
Yeah.
I will share. We'll share that.
Great. Thanks, Inmay. Thanks.
We'll see you next Saturday.
Thank you.
Bye.
Yeah, thank you.
Thank you.
Thanks.
Thank you.
Bye.
Thanks.
Bye.
Bye.